ready to introduce our first speaker for the day. Good. So I am really, really excited about our first speaker. So this is somebody who I have been following and who I have admired in the world of CSS for a really, really long time. And I'm super excited that we finally get to meet and I get to see her talk in person. So I've been a fan of Miriam since the Suzy grid system, way back in the olden days before we had, good Flexbox and before we had grid and all of these lovely, wonderful things that we kind of take for granted in CSS now. So Suzy was like the first, it was a SAS grid system. I don't know if any of you remember it. Yeah. And it was, the first one that I felt like, this is how we want to be doing grids. This is kind of the best way to do grids now in CSS. And obviously, since then, we don't need grid systems because we have, actual ways of building grids in CSS. We have Flexbox and we have grid. So we don't need those anymore. But Miriam has been doing amazing work. She's a spec author. She's worked on container queries, on scope, on a whole bunch of other stuff. She's continuing to revolutionize CSS, I guess. So I'm really excited for her to come and show us this new amazing CSS today. So please try to contain your excitement. Thank you. Welcome to the stage, Miriam Suzanne.
Wow. Yeah. You all get some sleep? Yes. Good. I'm not sure I did, but it's good to see you all. Thanks for having me here. We're going to talk about containers. Containers. What do they know? Do they know things? What aren't they telling us? Let's find out. This is an old question we've been asking for ages. What do containers know? Do they know stuff? And we've been asking this ever since Media Queries came out in 2009, Safari in 2008. The rest of the browsers in 2009. And media queries are pretty cool because, let's just present that. We can, okay. Wi-Fi. All right. Media queries are pretty cool because we can measure the size of the viewport and we can say, let's go horizontal when we've got enough space. That's pretty rad, but then what if we add a sidebar? Oops. That falls apart pretty quickly. We don't really want to measure the size of the viewport for this. We want to measure the size of the container that something is in. You might call it something like a container query. And containers can be all over the place, and we can have many of them, and they can nest inside of each other. There's all sorts of things that we might want to measure. In 2010, Ethan Marcotte wrote the famous responsive web design article, gave the talk. And already by 2011, we had a selector queries polyfill that was trying to do what we now call container queries. So right away, container queries were the big question to come out of media queries. And we've called them many things over the years: selector queries, element queries, container queries. And sometimes they meant the same things, sometimes they meant slightly different things, all the same sort of idea. In 2018, Philip Walton made this site of demos of things we might want container queries for. We've got a card on the one side that's changing based on its container, and then the calendar changing. Lots of different use cases for this. 2019 container queries were the most requested feature on the State of CSS survey. And browsers could hear us asking this: do containers know stuff? And they answered with one voice, maybe Tab's voice, maybe in this room, maybe several years ago. They said, no. Containers do not know stuff. They don't know anything. It's not going to happen. Stop asking. Thank you. Any questions? Container queries will never be possible on the web because they would cause infinite layout loops. We've heard this a lot over the years. Please do not query the containers. They're not going to tell you anything. But would you like some very flexible boxes in the meantime? And they are very flexible. There is a lot you can do with these boxes. They move around, they resize, very powerful. And we got grids. And they also move around and resize in really interesting ways. We can even, we can different number of columns at different widths. You don't need Susie anymore. I'm sorry for Susie. Moving on. We got into an era that Jen Simmons has called intrinsic web design, an evolution of this responsive web. It's still responsive, but responsive web design, this is the talk that she gave, everything you know about web design just changed, it's worth checking out. Responsive web design relied on removing the sizes from everything and replacing them with percentages. Everything becomes a percentage, everything is fluid. And that worked for us for a while. It works with floats pretty great. But intrinsic web design says now we have enough tools. We don't need to remove the sizing from everything. We can keep the sizing there. Some things can be based on pixels. Some things can be based on ems. Some things can be fluid. It's OK. We can combine things that are sized in different ways. We get truly two-dimensional layouts combining fluid and fixed media. We get different stages of squishiness, nested contexts that expand and contract, and then media queries only as needed, because in some of these cases, we don't actually need the media queries. They've become somewhat obsolete. I mean, here we've got a flexbox layout, and it's able to wrap, and it's able to resize. As we change the size of the viewport, things move from one row to the next, and same with grids. We can have auto-fit or auto-fill columns, and fill in the space as we're able. But wait a second, nested contexts that expand and contract with their content, that sounds like something we might want to measure and query and respond to even more. So media queries in some ways became a little bit more obsolete, but suddenly we need container queries even more. And we're not in 2020 anymore. Thank God. We live in the future with, no, cars. And, no, nope, hard no. Autocomplete, yes, the future. And containers know stuff. We found out. Finally, in answer to our question, container queries are now supported in every major browser, back several versions, which is pretty wild. And they solve this problem. We can now, let's pull that up. I think we've got a media query here, so we still have that. Okay, we've got the sidebar. We've got a media query. What we're going to need to do is create some containers. And then we change, is this large enough? We change @media to @container. And there we go. So how did we get here? Why does it work when it shouldn't work? Clearly, to fact check past Tab and everyone else, including me, clearly container queries are possible on the web, we think. But what about those infinite layout loops? What happened there? Why are they not a problem? So in order to understand how container queries work, which we'll get to, we have to understand why they shouldn't work. And they shouldn't. And this goes the whole way back to the beginning of the web. We've got the first browser, the www hypermedia browser released by CERN, and it's designed for this next machine with this fancy graphic interface. But that's not how the web is supposed to work. What if it worked on this machine? that was popular at the time. How are we going to do that? It doesn't have that fancy graphic interface. So they released a second browser, intentionally less featured, the line mode browser, which is completely keyboard controlled. You can telnet into the system. You don't even have to download the software. You telnet in and use the browser from CERN's machines. All through the keyboard, no graphic interface. And this becomes the mission statement of the web. Web for all, web on everything. And everything is a lot of things. There's a lot of stuff, and the web is just getting all over all of it. Here, I'll let Hayden tell you about it.
The small web of knowledge this created consisted of prose that would wrap and form lines of text to fit the window of any computer's web browser software. It was only much later, when some clever decided to put width 1024 pixels on an HTML element, that we would begin to massively with this perfectly serviceable display algorithm.
Yeah. So, that display algorithm that was perfectly serviceable is called normal flow. That's how we refer to it now. And it's the layout engine that we get before we change the display to grid or flexbox or something else. We get a block context with normal flow. And normal flow is pretty powerful. We've got a lot of boxes here, nested boxes, and when I resize the outer box, the other boxes flow and move. Like, this is shit that InDesign can't do. It's wild. And we can even change the content, and that changes the size of the box also. What? So these boxes change size based on the content inside of them and also on the context outside of them. We've got layout information going in and out to get the final layout of the page, which is pretty clever. And it means that every box starts with an intrinsic size. I mean, that intrinsic size might be 0, but every box starts with an intrinsic size based on its contents. And then it also, some boxes get an extrinsic size based on their context. Block elements are 100% width by default, so they get that extrinsic size. And then we've got an algorithm for determining when the intrinsic or the extrinsic size wins and how they compete and what other, we can add attributes and properties that also provide extrinsic sizing or even change the intrinsic size, override the intrinsic size. And it's pretty fucking cool. Like, this is a powerful algorithm that makes everything else we do possible. It's what drives autofit and autofill and all of the flexbox stuff. It's what makes the whole system work. And it's what makes container queries impossible. We won't be able to do them because of normal flow. We've already shipped them, but we won't be able to. Because for queries to work, we can't change the thing that we are trying to measure. That's pretty fundamentally broken. If we can measure a thing and then change it and then we try to measure it, it's going to break. So that means we can't style the container that we want to query. It means we can't style anything that might change anything about the container we want to query, so nothing about its context. And for size-related queries specifically, we have to turn off intrinsic sizing. They cannot be intrinsically sized if the content inside is going to change when the container changes. We have to break that loop in order for this to work. And this CSS containment, it's a very little used feature otherwise, but it's in a lot of ways what we were waiting on. This had to land first, and CSS containment is a promise from a container that certain things won't escape that container. And we've got different types of containment: size, layout, style, paint. And size containment is the main one that we need here. Size containment removes all intrinsic sizing. It says this box should lay out ignoring its children, which is pretty risky. Some of you might know this meme. I mean, it's easy to fix. But yeah, let's look at it a little more. So there's various ways that we could fix this. We could Get rid of that min width, make it intrinsic. That's a solution. We could do some overflow wrapping or something that's not perfect. Or we could use containment. Let's contain the size and layout. Yeah, that'll work. So removing the intrinsic size of things is a bit risky and necessary. But what we then needed to wait on was some way to, what if we could contain only the width of things, only the inline axis, and still let content flow and change the size of the block axis. So this was the goal, because in most cases, we're doing web layouts where we give an extrinsic size for the width, and we allow the height to grow and shrink with the content. So if we could make that work. But there were a lot of problems with that. One is demonstrated here. One of the first things that I did when I started working on this spec was document all of the reasons it wouldn't work so that we could go through them and see if there were solutions. But this one, so we've got a bit of text up there, and you don't need to be able to read it. But as it gets taller, these pink boxes are floated. As the content gets taller, it becomes too tall for that space, and then it jumps. And now it's in a space that's wider, so now it's short again. Now it's short enough to fit in the top area, so it should jump back up there and try again, but it doesn't. And this is actually the solution. I made this demo, and then one of the Chrome developers said, yeah, we already solved it for floats. There's a recursive loop here, and we just stop the loop. We just don't loop back. We always move forward with the layout engine, and that's the solution. So it was solved years ago. But we still do need the containment, so we were still waiting on some things. We aren't able to do this in the other axis. When you change the block axis, there's too many situations where changing the block axis can then change the inline axis. So there's no way to cut it off in quite the same way. But we can only measure the axis that we contain. So if we want to measure height, we're going to need to contain both dimensions. So contain size allows us to measure both. Contain inline size allows us to just measure that inline dimension. But size containment is intense. It does remove all intrinsic sizing, but there are cases where we can do that, mainly when content is going to overflow. If you're setting overflow scroll on something, that's already removing the intrinsic size of the contents because you're allowing the contents to scroll. You're not basing your size of the box on the size of the contents. So when you're creating a scrolling box, that's a safe time to lock down both dimensions, and then we can query both dimensions. So here's a demo that shows several variations of that. I mean, mainly in these sort of application layouts where no matter what we do, the main content is overflowing, that nav sidebar is overflowing, and so those are safe to contain on both axes. But if we tried that with the articles, they would collapse. Yeah, there we go. So we don't want to use it there because we need somewhere for that content to go because it's being sized based on its contents. We also run into problems here if we do something like, I have them in a grid there, and by default, they are justified by stretching, which is giving them an extrinsic size in the grid. The grid is defining the size of the articles. But if we remove that by justifying them to the start or to the end or even to the center, we lose that extrinsic size coming from the grid, and they collapse again. So we need to be careful with our containment. We're also going to need layout and style containment, and these get a little bit weird. So I've got two figures here. I'm using a counter to get fig 1 and fig 2. Oh, and this kid is just disappointed in you, and I'm so sorry. But whatever you did, you should feel bad about it. Right, so we've got a container here around the second figure, and we're going to try to put different types of containment on that. So let's actually start with style containment. And by containing style, the main thing that it does is it stops counters from getting in and out. And this could be a problem for container queries because those list marker counters could get bigger or smaller outside the box and then change how much space the box has. So we have to turn off counters. So that's one of the things. We've already looked at what size containment can do. It collapses that element, but because it's a block element, it's still getting the full width. So in this case, inline size would work for us. That doesn't collapse too much. But the other thing that we're going to need is layout containment, which just says nothing in the box is going to affect the layout of things outside of the box. And that means even our position fixed element jump down into the box. That's going to be a big surprise for you, except that I told you. So no excuses. The other thing that happened there, that position fixed element was a higher z index than the first figure. And when I added layout containment, that z index is now also contained by the box. And that box is below the first figure, and so the z index of the fixed position element is also contained. We've got a new layout context, which means we have a new stacking context, which means all of this can happen. Good luck. Good luck out there. So because containment is this invasive, we only create containers explicitly. There's no containers created for you. You have to decide what can be a container so that you can lock down these certain things, work around that, and do the measurements that you need. But you don't have to remember all of the individual contain properties. You don't have to go directly into contain, inline size, layout, style. Instead, you can just set a container type, and the browser will apply the proper containment for you. So you can just say container type inline size in most cases, or in some cases, container type size. For legacy reasons, there's no default container even on the HTML element, because that would cut off certain properties propagating from body to viewport. Like if you set a background on body right now, don't do it. If you set a background on the body and no background on the HTML element, the body's background will be added to the viewport. And even if the body is small, that background will apply to the whole window. It's not a good thing to rely on, but we couldn't make HTML a default container because of that, because it could break old sites. But it is safe to do as long as you're not relying on that behavior. So I would recommend adding this to resets. If you're starting to use container queries, you can say, make sure that the HTML is taking the whole viewport height, and that gives it an extrinsic size. And now we can measure the HTML element. And then we can just take our media queries and change them to container queries. We can also use the range syntax. That's shipping in all the browsers at the same time, both for container queries. I put it in the container query spec, and so they implemented it for container queries, and then they also implemented it for, great. You can also use the logical dimensions. In a container query, they're going to resolve based on the container's writing mode. So inline size will be the container's inline size. I believe that's true. Runa will correct me later if I'm wrong. And this range syntax also allows you to do multiple values. So you can say if the inline size is greater than 20 ems and less than 40 ems. And you might think, why bother? We've got media queries. I can already measure the root element. And sure, but container queries measure actual styles on the actual element, the computed values on the container element. And that is different from what media queries are doing. So with a media query, let's see. So the media query at 20 ems is changing the border there. And you can see that happens at a pretty small size. It's adding that border. And the container query is changing the background. Both of them are doing it at a min width of 20 ems, and they're changing at different times. And that's because we've got a font size set on the root element that is a larger font size than the default font size coming from users. So the container query is responding to the actual computed font size on the HTML element, while media queries only respond to the font size of the medium, which is defined by the browser and the user and has nothing to do with the properties you set. So this is the reason you might want to switch all of your size queries over to container queries, even though in a lot of cases they'll be similar. For the sake of progressive enhancement, a browser is only going to do the stuff inside of a container query if it supports container queries. So there's your positive, things that should only apply when container queries are supportive. You can put them inside of a container query. And then you can use supports not container. You can put any value in there, really. Supports not container, that can be your negative for things that should be applied when container queries are not supported. There's also a polyfill from the Google Chrome Labs. So you can use that if you're the polyfilling sort. I don't know what that says about you. It's also recommended that you name containers. So there's a container name property, and you can give a container as many names as you want and any names that you want. These are your values. Use them how you want. I find it useful to think both in terms of sort of IDs and classes. So the root element it's a layout container, which is going to be a class of containers I'm going to reuse, and it's also the root container. And then I can query either one. There's also a shorthand. So instead of saying container type size, container name, layout, root, I can do that all in one. The name comes first and is required in the shorthand. So if you're not doing the name, just use the container type. But it's recommended to give containers names. Then you can reference them when you need to. The reason to reference them is, actually, I'll get to that. Like I said, names can be like classes or IDs. I use sort of a combination of the two, some unique, some not, and then I can query whichever I want. But to find a container, every matched element inside of the container query, so it's going to say, OK, you put an H2 inside of this container query. We're going to match every H2. So every matched element then has to look for its nearest ancestor that has the required container name and the proper container type. And it's going to look, and it's going to see if it can find one, and if it can't, the container query fails. If it finds a container, then it will do the measurements and then return true or false based on that. But that's the reason. What was I saying? I got lost. I'll have a drink of water. So each matched element is going to go find its nearest container. Right. So the reason you might want to use a name is that it's the only way to skip containers, to say, I want to actually measure the container that's 2 or 3 above. Otherwise, I'm always going to get the nearest one. If I add names, I can jump up and get 2 containers up, which is sometimes useful because you're changing a layout based on an outer container, but you've got inner containers you're using for something else. You've already seen it in practice. I don't need to show that one. Containers can't self-query. Every element that appears in a container query will contain an ancestor, the nearest container ancestor that matches the criteria. So a container can't query itself, can't respond to its own size, because that would introduce the loop again. But containers can query other containers. So we can nest these however we want to. Right away, Eric Portis made this just to test he was doing a stress test to see if we were going to break the browser by having too many nested containers. And as you can maybe see, in the future, so he's changing each container is changing its border based on the container outside of it. And it works pretty well there in the 36 chambers. I did count last night to make sure. So each one is always measuring an ancestor. We can't change the thing we measure. That would break all of the rules, like time travel or something. We're also always measuring an element. We're not measuring some abstraction. We're always measuring the size of an element. I think the content box of the container, which is a little bit awkward when we get to grids and flexbox, because really, we often want to know what is the size of this flexible element inside of a larger container, or what is the size of the grid track. And we can't measure those directly with container queries. I recommend turtle components that carry their containers with them for this case. It's an extra wrapper, but it allows us to get around that need to change something other than what we're measuring. So you can see that working here in a flexbox layout. Please hold. So we've got these card wrappers around our articles, and then the card is a container, inline size container, and it is the flex element, and then the article is responding to the flex element. So it goes from vertical to horizontal to wild and big. And you can see each individual one is able to do that because each one is measuring its own container that it carries with it. Max Book, who's here, made this great demo showing that that works especially well with web components, where the host is already a container given to you for free. So you can just treat the host as a container and then measure it for the layout of everything else. So he made this bookstore. We can drag the books. I guess we always need something featured. But it's the same component, just moving around, and depending on where we drag it, we get a different layout, which is pretty cool. So use the host element to give you your turtle shell. We also get container query units. These are similar to viewport units. You know, you have VW, vmin, vmax, all etc. We also get CQW, CQH, CQI, CQB, CQmin, CQmax. These are units to use in the same way as the viewport units, but they will measure a container if it's available instead of measuring the viewport. So this is just a quick, I can add more articles here, and both that little heading and the font sizes are changing based on the amount of space available in each container. Here, these are both the aside and the main area. They have the same font sizing, but it's using CQ units. So the text in the aside is smaller. Scott Kellum made this larger demo showing off that sort of resizing inside of a grid using CQ units. And for CQ units, we felt like it was a little too dangerous for CQ units to fail when there's no container. So they fall back to the viewport. If there's no container available, they'll give you the same as the small viewport units, which were released recently, which means the viewport with all of the Chrome in place. Here's Max. Yeah, so small viewports here from Brahmas's article. As Yuna showed yesterday, there's interesting ways that this can be combined with has to only apply container queries in certain situations. And then I found her actual demo and just put it in my talk. So here's a bunch of elements using a combination of has and container queries so that only when the card has a visual and the container query matches, then it does the container rearranging, which is pretty cool. Thank you, Una. Una also made this button where both the icon and the button itself respond. So that plus is part of the icon gets simpler, and the button changes. Both are changing based on media query or on container queries. And I think the great thing about this demo, you can put this button inside of a card that's also responding to container queries. There's no right level for container queries. It's not like they're just for layout or just for something. We can nest them and have all sorts of different things responding to the size of different containers. Here's one from Martin Van Hoof, who's also around. Let's get that one inspected. So this is a weather widget that responds to the size, and I think also the vertical size. Oh, right, there's a handy little handle. So we get all sorts of different layouts here based on that. You can see in the Chrome Dev Tools, we can see containers. There's a little thing we can, a little pill we can toggle to mark our containers. So that's pretty handy. And we should also be able to see, I imagine, down in here, container queries, and I think it's telling us which container there and what size it is. So there's a lot you can find in the dev tools already for working with container queries. Oh, whoops. I went out too far. Here's one from Jay, who will be speaking later, just in case you wondered about the CSS blinds. That's just making a container larger and using way too many queries to make changes at each side. Okay. Page unresponsive. Good. Steph told me that my containers don't hold water, so just to prove Steph wrong, here we go. Well, that's probably not water. There we go. This container does hold water, Steph. And containers know other stuff too. We have style queries. Una and Hayden both mentioned these, so we can just use the style function and query the value of a custom property. So this was Hayden's example with a scope test. And I actually adjusted that a little bit last night and thought, one of the testing things that I do sometimes is add borders to everything. So I have this, when the root container has test set to true, we'll add a medium dashed red border to everything. And if we turn on that test to true, there we go. We're querying the value of that property on the container. I also have my own version of this. So I've got a button. I've got button themes, and I can change that theme. If I remove it entirely, I just get the normal button style. But then I'll add the Mia theme, and then the Mia Plus. Yes! So we can use it for theming like that. I've also, so that style, currently that only works on custom properties. It doesn't yet work for normal properties for now, maybe forever. We don't know. Yeah, good. We'll see. Hopefully that will work on normal properties at some point, at least some of them, but no guarantees. Browsers are suspicious that that might be hard, so I can't make them. There's no containment required for style queries. They just work, and often, because styles are inherited, you often want to just query the direct parent. So that's what happens by default. Everything is considered a style container. When you do a style query, it queries the direct parent unless you set a name. I said that. So yeah, here's another one, auto light dark. This one, again, is using container queries, container style queries to do that. I'm checking the color scheme and checking whether current scheme is set to dark or light to change the colors. This is using components, web components, and passing in different properties. So using custom properties as ways of sending props to a component. So we can say the theme should be light or the grid should be flipped. We can turn any of those off and get the default. There we go. Or the media should be round. So we're using these to just define what the variations of our component are and then pass in the values that we want to get angry child is still really disappointed in you, and I'm sorry about that. We can use generated content. So this little arrow is generated using the after pseudo element. That is technically inside of the container, so it can query the container. So we can have that arrow position, the bubble, when arrow position is set, we add the little arrow and we position it. And then we can pass in different values there to actually position the arrow. So handy to know that generated content is inside of the container that generates it. There's a little bit of a weird thing, and Manuel wrote a great article about it, which I link here. But we're measuring the computed value on the property on the container, which can get a little bit weird. So we could say here, okay, brand is set to red on our container, and the background is set to brand. So we would expect here that maybe we should get the thick, solid teal border, but we don't, because red is not the same as, wait, let's see. Okay, the background is set to F00, which is also red, but they are not equal reds right now because one is the word red and one is #F00, and those are not the same thing. If we said the background equal to that hex color, then we should get the styles. There we go. But there's other things we can do. We could say instead, let's teach the browser that background is a color, and it should be resolved as a color. And now it correctly figures out that because we know that background is a color and we're checking the computed value of background, we're going to resolve both of those, and red is equal to F00. So that's a little bit of a gotcha with how these resolve, and a good use of the @ property. Style queries are not as well supported. Some browsers are skeptical that even this is implementable. So if this is something you want, go make some noise about it. There are also uses. This is just fun. Okay, there are also uses for normal properties that I would love to see. Like if we've got an emphasized text inside of a block quote and both are italic, you're going to lose it. So we really want some way to be able to say sorry, this is small, but if the font style is already italic on the parent, do something else, like provide a background color. That would be really powerful. It's not possible yet without having a second custom property that tracks whether you're in an italic state or not, which is a little much, but you can do it if you want. There's other things that I think would be interesting here, like measuring the padding, see if the padding is above a certain size, and then we can outdent our lists. And maybe there's other questions that we have for containers. Maybe state queries. These also got mentioned a little bit yesterday. Can we check to see whether a container is positioned sticky and currently stuck, or in a snapped scrolling context and currently snapped, or overflowing? There might be other states that we want to be able to measure. If you have ideas, let me know. As Una showed, Runa has pushed a first prototype of the stuck state query, although I checked Chrome this morning and I didn't have the new canary, and so I can't show it to you. I have a demo ready, but no. So to answer our long-standing question, do containers know stuff? Yes. Containers know stuff. They know their size if they're contained. They know custom property values. They know relative values like the size of an M. They know maybe some states. We're still figuring that out, and let us know if you have other states that we should try and query. And yeah, what the fuck? That's not how we wrote CSS 3 years ago. Sorry, spoiler. That's coming later. They're contained. Ask them anything. Thank you.
Wow.
I should show you quick.
Ooh, there's more. Hang on.
I'm using container queries for my presentation there. That just seems relevant.
Come join us. Come join us. Wow, thank you so much, Miriam.
Thank you.
Hoist myself up onto here. Yeah, I mean, that was absolutely amazing. I spoke a little bit about container queries last year, but like there was so much more in this presentation, and coming from a spec author. Yeah, like especially I liked how you explained about why block querying the block size does not work, because people ask me that and I'm like, yeah, it doesn't work for some reason that we just
reason.
Yeah, we can't do that. There's some reason. But yes, thank you. I really appreciate that explanation and everything else in your talk. It's just incredible. And we have a ton of questions for you as well. So let's get through as many of these as we can. Okay. The first one is from Roy, and I think you kind of answered this a bit. I don't know if you have anything to add. What's the best way to handle iOS devices that still run on iOS 15, where container queries are not supported? I mean, you did talk about browser support and the polyfill. I guess that's kind of the best way for now, right?
Yeah, either the polyfill or having a media query as a fallback. Mm-hmm. Yeah, then you're maintaining two. I don't know, you know. You could maybe have a SaaS thing that does but yeah, I think at this point you're deciding whether the fallback is worth it, whether the polyfill is worth it, or whether you just wait another couple months. Yeah, that makes sense. The next question, this is a good one, actually. So for responsive images, using the picture element with different source sets, and those rely on media queries, is there a way to use container queries for the picture element? There's a big thread trying to figure this out. So the problem is we want to load images as quick as we can, and that means as soon as we get the HTML, we want to already start loading the image. And that means we don't want to wait for all of the layout to finish and then go get our images based on how that layout resolved. So the one workaround might be that we could say, okay, lazy loaded images, we could have a way of saying, these are lazy, so therefore wait for the layout, then apply the container query. So maybe there's a path forward there, but it's not solved yet. I see. Yeah, that makes sense. I'm looking forward to seeing how that pans out. It would be very useful. How does containment work with the top layer? Is the next question. Yeah, they're unrelated mostly. So things in the top layer can be contained, and things outside of the top layer can be contained. I don't think they should impact each other at all, as far as I'm aware.
Okay, thank you. Do you have any further best practices you've discovered, like refactoring from media queries to container queries? And that's from Peter.
Not particularly, besides like, once you can do it, I recommend it. I was talking to Runa a little bit yesterday about performance, and we don't know of any specific performance issues. It's not like the more containers you have, the more it's going to hurt performance. There are likely combinatorial performance issues. I think Sana ran into some yesterday, where container queries interacting with some other feature might cause performance issues. So you'll have to experiment and let us know. But yeah, pay attention to that. But in general, we don't think it should be a problem to add as many containers as you need. I wouldn't go around adding containers universally. That seems pretty risky. But otherwise, yeah, play around.
That's very good to know, because that was going to be my question, is how many containers is too many containers?
16.
And that presumably includes when they're like nested and nested and nested. You still don't have
Yeah, there
issues
shouldn't
with
be problems with nesting them.
Amazing.
Let us know.
Yes, containerize all the things. You heard it here. And this is a good question, and you might not know the answer to this just yet, but what are any good public sites or apps that use container queries in real scenarios in an exemplary way? Or just any way, it's fine.
I don't actually know yet. Awkwardly, people don't tell me every time they use container queries, which is rude.
There should be some sort of alarm that goes off.
There should be an alarm. Yeah, in my room, like a red light that spins. So if you know of any, maybe use the hashtag or whatever and let us know, because I'm curious too. I don't know.
There was another question on here that's mysteriously been deleted, but I think it's kind of still relevant. It's about media queries versus container queries, which you showed really clearly there. You know how they're different and why you might want to use a container query or not on the root element as opposed to a media query. Are there any other situations like where you would use viewport media queries still as opposed to container queries? Or do you think once container queries are supported everywhere and we can comfortably use them, that we just won't really use those anymore?
I don't know about viewport media queries specifically. Maybe there would be cases where I don't want the actual font size to have an effect, and I want to know based on the default font size something. There are lots of other media queries that I would still use, like the preference queries, prefers reduced motion, prefers color scheme. There's lots of other sort of things that we actually do want to know about the media that we should keep using media queries for. But in terms of size queries, I think I would pretty universally switch unless something comes up that I haven't thought of.
For sure. Oh, well, that's good to know. And yeah, obviously, yeah, media queries are not dead because they can query, as you say, so many other things other than size. But thank you for that. Thank you for that wonderful talk and answering all those questions.
Thank you.
Please, yep, another round of applause for Miriam.
Thank you.